Firstly, let's look at the circuit diagram. As you can see here, this time I am using an AC voltage source. The equation for the supply voltage is Vm sine omega t, where Vm is the peak amplitude of the voltage waveform. According to this equation, we can have this following waveform. As you learned before, during the positive half cycle of the supply voltage, electric current will flow from the positive terminal of the voltage source. Therefore, the current will flow to the anode terminal of the diode, and as a result, the diode is in forward bias and it will act as a short circuit. Therefore, current can circulate in the circuit through the diode. Since the load is a resistor, hence the wave shape of the output current waveform is following the supply voltage waveform, but with small amplitude. Hence, we can sketch the output current waveform like this. Next, by analyzing the circuit, we can also sketch the output voltage waveform across the resistor. Now, the supply voltage waveform is in the negative half cycle. For this condition, the current will flow from the negative terminal of the voltage source to the cathode terminal of the diode. As a result, the diode is in reverse bias and it will act as an open circuit. Therefore, no current can flow through it and the output voltage is also zero. Based on this information, we can sketch the output voltage and current waveforms like this. Now, I will change the power switch to a thyristor. As explained before, this power switch requires a gate signal to operate. Based on the initial position of the gate signal, we can see that the thyristor is in forward bias when the gate signal is applied during the positive half cycle of the supply voltage. After the gate signal is removed, the thyristor is still in forward bias as long as the supply voltage waveform is positive. Nevertheless, before the gate signal, the thyristor is in reverse bias even though the supply voltage waveform is positive. On the other hand, during the negative half cycle of the supply voltage, we can see the thyristor is in reverse bias although there is a gate signal. Thus, the output voltage and current waveforms are equal to zero. Next, let's see whether the width of the gate signal affects the operation of thyristors. As we can see, after I increase the width of IG, we can see the output voltage and current waveforms on the left side are similar to the right side. Hence, The width of the gate signal does not affect the thyristor's operation. Based on these waveforms, we can say that the operation of thyristors only depends on the starting time of the gate signal.